Thank you. OK, we've got 117 slides in this talk, so I'm just going to get through it. Hello. So CSS for software engineers, for CSS developers. Quite an obscure and recursive title. What we're going to be looking at during this talk is taking some really traditional software engineering principles, applying those to CSS work. So we're going to write CSS from the point of view of a software engineer, so that we as front-end and CSS developers can really start to reap the rewards of those paradigms, those principles that make traditional computer scientists and software engineers efficient, pragmatic, and practical in the work that they do. I spent a lot of my career doing this, basically stealing things from people cleverer than I am. Before we get on to that, I want to go through a really brief bit of a history lesson, just to try and set the stage. And that history lesson starts with these two. This is my mum and dad on their wedding day in 1984. I have no idea what she was thinking. But they got married in 1984, and my mum and dad are really important to me because obviously they're my parents, but they also provide me with a very obscure and very specific, but very helpful professional benchmark because both my mum and my dad were born in 1959. 1959 was also the birth year of what is widely regarded as being the first modern programming language. This is a useful benchmark for me because when I start to think about how old programming is, I know exactly how old. It's the same age as my mum and dad. It's a very useful benchmark. That first programming language is called Cyclomatic. No prizes for guessing which country invented this. It's the most American-sounding name I ever heard. But it was developed, and it's widely regarded as the first modern programming language because it was the first one that used actual English words to produce control flow. And it was developed for 4 years from 55 until 59. It's a pretty contentious issue. There is no real definitive first ever programming language. But for the sake of my presentation, for the sake of my argument, it's helpful that we go with this. It's the first English-like language. It was developed by a woman called Grace Hopper. I can't really see many of you, but who's heard of Grace Hopper? Oh, that's good. Right. So those of you who haven't heard of Grace Hopper, I urge you to go and look her up. She was a very important person in the birth of modern computing, I guess. She did a lot of work for the US Navy, and it was her and her team that developed Cyclomatic, and then that gave rise to other languages like COBOL. She's a very important woman. Has anybody ever seen archival footage of Grace Hopper teaching? Okay, a few of you. Anybody who has seen footage of Grace Hopper teaching probably gets the impression she's got a very can-do attitude, very inspiring, very strong woman, and nothing sums that up better than this for me. Basically, her managers didn't believe what she was proposing was feasible. They just thought it couldn't be done. How could you write a language that looks like English but can control a machine? And rather than being put off or disheartened, she just rolled her sleeves up and did it anyway. I think that's really nice. Back to this timeline then. So it's a very personal timeline, but knowing these dates, knowing this about the first programming language, lets me draw up something that looks a bit like this. This is very personal to me because the data on it is, well, my parents were born in the same year as Cyclomatic. I was born in 1990, and my sister and CSS were both born in 1996. Oh, that's my sister, by the way. Horrendous. She doesn't know that's in here. So this timeline, for me, is really useful because if you think about the difference between when my parents were born and when my sister was born, it's 37 years. It's a really long time. That was enough time for my mum and dad to be born, get educated, to a degree, find each other, fall in love, start a family, have careers. 37 years. The difference between CSS and the first programming language is the same as the difference between my little sister and my parents. It's such a long time. Now I'm thinking about two people there, my mum and my dad. Think about the collective knowledge of tens of thousands of pioneering software engineers. Think of what they could learn, what they could do in 37 years. So this for me is really useful because I see that 37 years as somewhere to just borrow ideas from. The saying, those who don't know history are destined to repeat it. I really believe this. In front-end development, we've been discussing things like performance in mainly the last sort of 5 years. I've been dealing with large-scale architectures for the last 3 to 5 years. A lot of front-end development gets discussed like it's something new, but for 37 years, people have been doing this in other realms. So this talk is going to look at some of these specific principles and how we can apply these very, very traditional computer science techniques and paradigms to front-end development. The first principle we're going to look at is the dry principle. Who's heard of this? Who's heard of dry? Cool, right, don't repeat yourself. It's a very simple principle. There is some misunderstanding around it, so we're going to cover that in a second. Who's heard of the single source of truth? I thought so slightly less of you. The single source of truth is a slightly more philosophical paradigm that sits behind dry. So we'll discuss both of these and this air of confusion around them. The dry principle basically states, don't repeat yourself. It states that every piece of knowledge must have a single, unambiguous representation within a system. There's a really important word on this slide that most people seem to miss. And, well, I haven't highlighted it, of course you're going to miss it. It's the word knowledge. The word knowledge in this definition is really, really key. Dry isn't about avoiding repeating anything. It's about avoiding repeating knowledge. So that's one of the confusions around dry, is that any string must not appear more than once, and that's not the case. Any bit of knowledge should not appear more than once. So yeah, every discrete piece of information should exist once. Information, knowledge. It's not about any string in a project. You shouldn't need to make any change in more than one place, ideally. Who's ever inherited a project where you've made a change and it's not reflected where you thought it would, and then you found out, oh, you need to change it somewhere else as well, and maybe somewhere else? Who's had that before? Yeah, right. That's a violation of the dry principle. This adds a lot of cognitive overhead, adds a lot of confusion, because the first thing that happens is you have to look around for these other 4 or 5 places that things have been repeated. But then for the rest of that project, you have to remember that it exists in 4 or 5 other places. The cognitive overhead of repetition is really horrible, and it contributes to bloated CSS. This is one of the major factors, one of the major reasons why CSS gets so messy, because people just don't abstract things, they don't go back and change things. And this is how the dry principle can help to solve this. Start with a really simple example. Presumably we've all seen something a little like this before, some helper classes to nudge spacing around. Now these are all set to 12 pixels, and I'm presuming that's because 12 pixels is our baseline grid. So these 4 values are all the same for a reason. It's a key bit of knowledge. This 12 pixels is knowledge, it's information. They are the same for a reason. But we've written it 4 times, which means that if we change our baseline grid to perhaps 15 pixels, we've got to make that change in 4 places. Now that's not such a big deal, but let's say that somebody joins the project and they don't realize our baseline grid is 12 pixels and they want to change one value to 15. Then we get discrepancies. We get one of these set to 15 pixels and the other 3 to 12. We start to get inconsistency in our design. So drying this out is really, really, really simple. Just stick it in a variable. This is using Sass, but it could be using CSS or less or anything like that. But sticking this in a variable gives us what is known as the single source of truth. That key bit of knowledge now exists as $unit. That is what is known as a single source of truth. So that's where that fits into the dry principle. Slightly more in-depth example. Presumably we've all seen something like this before as well. Now, what we've got here is a custom font that is paired with a specific font weight. So I'm presuming that anytime we use custom font, it has to be rendered at font weight 700. So these are all thematically related. These 2 declarations are thematically related. They have to come together. They have to exist together. This is knowledge, this is information. The way I would dry this out is just by using an argumentless mixin. An argumentless mixin should be seen as an extension of copy and paste. A lot of people argue and state that argumentless mixins are bad because it leads to the same amount of repetition. It leads to the same amount of CSS after it's compiled. That's completely fine. The fact that this gives the same amount of CSS doesn't really matter. We could use tooling to reduce this. That's a job for a machine, not a person. The key thing is here that we're not typing anything ourselves. Dry is don't repeat yourself. It's not don't repeat anything. So generating repetition is completely fine. That's a slight, subtle misunderstanding that a lot of people have with the dry principle. Now, moving on to the single source of truth, this is the practice of structuring information models and associated schema such that every data element is stored exactly once. Very, very, very similar to dry. The distinction for me is dry is what you do, and a single source of truth is what you end up with. That's kind of the way I look at it. So it's much more philosophical. It's aiming to store everything that's important only once. It's not about repetition. It's about the integrity of data. Achieving a single source of truth increases confidence. It means you can make changes much more safely. You know that the change happening in one place will propagate to the correct other places, and it just keeps everything neat and tidy. The confusion around dry, then, is that we should be aiming for dry in source. So dry is a maintenance philosophy. It's not about performance, it's about maintenance. It's about not repeating ourselves. So repetition, to a degree, is completely acceptable. Repetition G-zips very well, so it's already, we can start to claw any performance hit back anyway. But it's not about avoiding repetition in general, it's specifically about avoiding repeating ourselves. So automating repetition, completely fine. Argumentless mixins, for me, are a really good example of how to tie that up into a single source of truth. I wrote a really in-depth article on this. Basically, if you type a declaration 50 times, that's repeating yourself, that's kind of bad. If you generate something, obviously you write something to generate that 50 times, something else is doing the repetition for you. It's completely fine. Seeing things like this happens quite a lot. We've got font weight bold here 3 times, but none of these 3 selectors have got anything to do with each other. These 3 rule sets are not related. A lot of people who strive for very, very dry CSS would try and abstract this font weight bold out into a shared single source of truth. It's purely coincidental. Because these 3 rule sets have no relation to one another, it's improper to tie an abstraction between them. It'll add a layer of complexity, and it'll create relationships that don't actually exist in your code. So we shouldn't dry things like this out. Going too far, trying to dry things too much, creates these awkward abstractions and structures and complex sort of formats within your CSS. It makes it much harder to maintain, which is completely violating the whole point of having a maintenance principle anyway. So yeah, use a preprocessor, store things that way. Generate as much CSS as you can without having to repeat yourself, get something else to do it for you. And the final point on this slide, there's a really, I think it's probably quite an old saying in computer science. It's that repetition is better than the wrong abstraction. As soon as you create an incorrect abstraction, you've added a layer of complexity that obscures things, and it makes things very hard to undo or unpick. It adds a layer of obscurity to your code. So if in doubt, just repeat it. Don't try and create an abstraction that will add complexity. The next principle, the single responsibility principle. Who's heard of this one? Okay, about half of you, that's cool. The single responsibility principle is probably the one that will give you the most bang for your buck. The single responsibility principle, incredibly useful for several reasons that we're about to look into. But if you're going to take one principle away from this talk, I would advise that it be this one. This will give you a lot more power when you're maintaining, writing, and composing UIs. So the single responsibility principle basically states that every class should have a responsibility over a single part of the functionality, and it should be entirely encapsulated. So it just means that everything should do one job only, one job very, very well. It manages to focus your intention on solving one task in isolation. We're breaking big monolithic things into individual tasks, and we do this all the time in our day-to-day life. If somebody asked you to build a house, it's a very confusing task, build a house. It's way too much to think about. So what you'd do is you would clear some space, then you would lay some foundations, then you'd build some walls. You break big tasks into small bite-sized chunks, into single responsibilities, to make things much easier to manage. You can put these tasks back together, get the same output, but you can solve things in a much smaller, granular fashion. And a surprisingly good example of this is Subway, the sandwich restaurant. When you go to Subway, you don't typically buy a sandwich. You choose the ingredients you want, you put your sandwich together, you're faced with something like this. So it means that we're breaking the idea of a monolithic sandwich down into a series of small, tiny component parts, tiny responsibilities. So Subway is actually, for me, it's the epitome of a real-world example of the single responsibility principle. Breaking everything down into its smallest possible part means we can put them back together arbitrarily and create very, very different outputs. In fact, Subway is that good at the single responsibility principle that you can actually create, let me read this, 6,442,450,944 different sandwiches. And they all taste the same. But you can really, honestly, you can make 6.4 billion different sandwiches just by breaking them into their ingredients. Someone did the workings out at the bottom of that slide. Purely by making a sandwich out of the ingredients alone, Subway offer you 6.4 billion different variations. Now, of course, you can go too far with this. I worked on a project where it was possible to have 96 different buttons. But what you've got to do is you've got to make sure that you use this wisely and break things down into discrete responsibilities. We'll take the sandwich analogy a bit further. So we've built a sandwich. This is a monolithic sandwich, which I think would make a fantastic band name. It's really hard to change things in this. It's hard to swap things out. It's hard to change and add new functionality. It's hard to reduce this into anything smaller without a lot of repetition, copying and pasting. By simply offering this sandwich as the ingredients, we can break this down into small, composable, single responsibilities. Now we can put these exact same ingredients together and achieve the exact same sandwich as we had before, but via composition. So composition over inheritance is a very important software engineering principle. This means if we don't like tomato, we don't need it. We can get rid of a little discrete bit. So the single responsibility principle, breaking large bits of UI into much smaller, manageable chunks, allows for much greater composition. A more realistic example. When you work in a team, if you work on a team that provides a style guide, perhaps, it's important that you provide your colleagues with the ingredients. Do not provide them with the meal. Give them the ingredients to make it themselves. It will provide them much more flexibility and much more choice. It's less opinionated. A more realistic example, I see things like this all the time when I work with clients. The first problem for me here is it's called button login. Right? Straight away, we can only use this button in one scenario, so instantly that's a problem. The bigger problem is that we're mixing responsibilities. We've got base responsibilities that just handle simple button box model things. We've got some structural responsibilities and some cosmetic responsibilities all in the same class. This is a monolith. Once again, this is a monolithic bit of UI. Simply breaking it down into individual responsibilities, separating our concerns, allows us to create much more granular and flexible bits of UI. It's much, much better, a much, much nicer way of working. And obviously we can extend this further. We can create different variants that we can compose in the DOM. We're not increasing the size of our CSS at all. We're not having to think about creating new names or naming conventions. We're writing very little CSS and providing ourselves and our colleagues with a much greater chance for composing in the UI, in the DOM, sorry, in the view. This leads on quite nicely to a principle called the separation of concerns. Now, who's heard of this one? This one's quite common. Yeah, quite a lot of you. Now, the separation of concerns is very, very closely linked to the single responsibility principle, but when you actually read this in detail, it's very, very philosophical. It's beautifully written. The actual definition is really, really, really long, and this is just a small section of it. But if you want to read the full definition, I would urge you do so. It's very, very well written. The separation of concerns isn't actually about code. It's not actually that tied to specific ones and zeros. What it's about, it's about the ability for a developer to think about their program. Can you consider the performance of a program separate to its syntax? Can you consider the syntax of a program separately to its functionality? So it allows developers to focus on one job at once cognitively. It's not necessarily about the actual code we write. Everything should be responsible for itself and nothing more. In CSS, we can apply this very, very literally. It could be a case of only bind our styles onto CSS-based classes. So don't style around DOM-based selectors. Don't put HTML into your CSS selectors because that means you can't change your markup without worrying about also breaking the styling. It means you can't necessarily change your styling without also having to be aware of your HTML. The separation of concerns trains you to have to think about one thing whilst ignoring everything else. Don't bind CSS into data attributes, and don't bind JavaScript onto data attributes. A data attribute in the DOM, it's your data layer. Right? This is where you store data. If you change your data layer to not use data attributes, you risk breaking your styling and your behavior at the same time. That's a violation of the separation of concerns. And don't bind JavaScript onto CSS classes. People do this quite a lot, and I've had clients where they would write a single class and they'd do all the styling on it and then all the JavaScript on it. They can never use one without the other. And if they change the name of that class in the CSS and in the view, but forget to do it in the JavaScript, it's going to start breaking things. So the separation of concerns trains you to think about one thing at once. Some specific examples. The top one, see quite a lot. Attaching styling to what is essentially an accessibility hint is very improper because now we can't make accessibility decisions without having to also be aware of our stylistic decisions. The header nav ul li we see selectors like this in the wild all the time. This is a complete violation of the separation of concerns. I cannot consider my HTML structure independently of my CSS architecture. Conversely, I can't change my CSS selector without having to also be aware of if the DOM might need to change as well. This is completely we're putting a lot of DOM information into CSS. People who argue against putting classes in HTML say that you shouldn't put styling information in your markup. The only way around it is to go the opposite direction and put DOM information in your CSS. Who even remembers the third example? Font color equals red. This is one of the main reasons CSS was invented. What we're doing here is we've got our markup layer, our content layer, completely responsible for styling, completely responsible for cosmetics. This is really bad. We can't change our content without also being aware or worried that we'll break our styles. This is, like I said, it's probably why CSS, one of the main reasons why CSS was invented. And putting inline styles in your HTML, so style equals, that's technically not the separation of concerns because, sorry, that technically is the separation of concerns. Putting inline styles is yucky and horrible and we shouldn't do it, but at least it is still CSS. This is literally HTML providing cosmetics. And the final one, yeah, binding JavaScript onto CSS classes. If in my CSS and my HTML I change this to nav primary, I also have to be worried or aware of the fact that I'm probably going to break my JavaScript. I shouldn't have to be aware of that. Taking a top example a little further, we might write some HTML like this, and presumably as responsible front-end developers, we do write our HTML first. But we might get to this point and we'll see, oh, perfect, there's a hook in the DOM. I can use that to style on, so then we start writing selectors like this. We're just loading our CSS with DOM information, complete violation of the separation of concerns. I cannot change my HTML architecture without breaking my CSS architecture. This is really bad. How we should really write this is like this, right? Substantially larger, but everything has its own job. We've broken it into single responsibilities and thereby separated our concerns. The first thing we have to think about is our semantic concerns. If CSS doesn't load, or a screen reader hits this, or a search bot crawls this, will they get the relevant, correct semantic information from my page? Everything else is an addition. If an assistive technology comes along, will they be able to get the information they need about how this actually functions? This is a separate concern. It should be applied separately. Our next decision is our stylistic concern. How are we going to style this? CSS is an extension. It's an addition to HTML. So we should add this as a separate layer. Our stylistic concern should live completely separately from our semantic concerns. Finally, we can add a behavioral concern. This means we can add or remove JavaScript without affecting any of our semantic decisions, without damaging any of our accessibility decisions, without ruining any of our stylistic decisions. Complete separation of concerns. A surprisingly good example of the separation of concerns is grid systems, and I mean the kind of grid system that's, div class equals grid col 6. They're not particularly pleasant to look at, but what they do is they completely divorce layout concerns from component concerns. I can now change my components without having to worry a single bit about where they might live in the page. Quite a controversial one right now, a violation of the separation of concerns, is writing CSS in JS. I was made aware of an article that Una tweeted, actually, by a guy called Keith Grant. Putting CSS in your JavaScript means you can't change your JS architecture without also worrying about your CSS architecture. You put all your eggs in one basket. It's either all or nothing. In 14 months, you find a new view library or framework that you want to try out, and you're out of luck. You'll have to spend a lot of time ripping styles back out of JavaScript and into style sheets. You can't have a JavaScript architectural decision without also having to consider your CSS architecture. That's a complete violation of the separation of concerns. So what separation of concerns does is it allows you to make granular, discrete decisions about your UI, or any program for that matter. Immutability. Who's heard of this principle? Cool, quite a few hands. Immutability, it's quite in vogue at the moment with JavaScript engineers. Borrows a lot from functional programming. So if you do a lot of JavaScript, you've no doubt heard of immutability from there. Immutability deals with mutations, the ability for something to change. A mutable object can be mutated. It can be changed after it's created, which means an immutable object cannot be changed after it's been created. An immutable object is an object that cannot be modified after it has already been made. This gives us a lot of confidence. This means that anytime we see something in a program or in some UI, in some DOM, if it can't be changed, we always know what output to expect. It gives us a lot of confidence when reading and debugging code, especially other people's. It reduces cognitive overhead. This is a phrase I use a lot. Cognitive overhead with mutations is huge. You have to remember exactly how something might behave in what scenario before you can work out what it's doing. If it never changes, you never need to think about that. It removes all of those caveats. A fairly solid example of this, imagine this is part of a grid system, col6 with width 50%, fairly common stuff. A lot of third-party grid systems will do something like this. As soon as we hit a small device, let's just make all the columns collapse into one. The problem is here we've mutated what col6 can do. Col6 is either 50% or 100%, depending on how and when we observe it. This is really, really bad. Col6 has one input, the class of col6, but two potential outputs. So we should never mutate. I mean, responsive design is a real villain in this kind of story. There's not much we can really do about it completely across the board, but specific examples like this with helper classes, it can be fixed. This kind of mutable state, these mutations, lead to a lot of confusion. And unfortunately, mutations are very, very common in CSS. The way I'd fix that specific example is I would use what I call these responsive suffixes. Just use a different class. So now we've got two completely different classes with two completely different jobs. This @sm just tells me @small. So here we're not mutating anything. We've got two classes with two outputs. Another example of how CSS mutates is it can actually leak into different unrelated parts of your project. The more astute among you may have noticed we've got a specificity mismatch here. The selector of subcontent h2 is actually of a higher specificity than text center, which means that in the HTML below we've actually got text center being overridden. Text center actually renders to be aligned left. This is a mutation. The subcontent h2 selector has managed to creep in and affect or mutate text center. So in CSS, unfortunately, unrelated parts of your project can affect different bits. Again, this is fixable, and the fix might make some of you cringe, but just stick an important on there. This is the only time I would recommend using important is on helper classes. These are completely immutable objects. Text center should never do anything other than text align center. This is how we fix mutation in utilities. Never use important in anger is a phrase I like to use. Always use it proactively, so do it before you need it so that you don't get these collisions. Another way we can mutate CSS, kind of by accident, is we've got a button here, right? It's got a set padding. When that button is put in a promotional area, oh no, it's the font size, sorry. We've got a certain font size. When we put that in a promotional area, we want to bump up the font size a little bit. Problem, we've got one class, two outcomes. We've mutated it. When we view button, there are two potential states that it could live in. This is really bad. This means that we have to be aware of these caveats and these conditions. We're mutating states. The fix is dead simple. Just use a different class. This is using the BEM notation, the two hyphens. Anyone not familiar with BEM, you don't really need to worry about it for these examples. But immutability is all about preventing one thing from having more than one state. So don't have several states of the same thing. Use modifiers in BEM or responsive suffixes, the @sm, in responsive design to avoid these mutations, to give things different hooks to bind onto. You can force immutability by using important. Basically, immutability can be brought on by specificity, unnecessary nesting, qualifying selectors. And that brings us really nicely onto the principle or the concept of cyclomatic complexity. Who's heard of this? Okay, not many of you at all. Cyclomatic complexity technically isn't a principle. It's actually a software metric. Cyclomatic complexity basically counts the number of ifs and elses in a decision tree. It counts the amount of options or potential outcomes in a function. So it's a form of static analysis that programmers would run over non-compiled source code. And what cyclomatic complexity basically does is it looks through the different, like, if this, do that, if this, do this, if this, do this, and it counts those branches on that decision tree. There's a function or an equation for working out cyclomatic complexity. I've got no idea what it does. All I really care about is that it counts the amount of paths through a decision tree. We can apply this to CSS quite simply. It's the number of ifs and elses. The higher the cyclomatic complexity, it comes out as an integer. The higher that integer, the worse we're doing. So we want a lower cyclomatic complexity. We want a smaller value. The way we can break selectors down to like ascertain or work out a cyclomatic complexity is by taking the selector. I'm sure we've all seen things like this in the wild. Selectors like this are quite common. Okay, so what I do with clients is I take some of their selectors, some of their worst offenders, And we write it out like this. What we're doing here is we're saying if there's a div with a class of media, if there's a section with a class of content, if there's an H1 with an A in it with a span inside that, then do this. That gives us a cyclomatic complexity of 7. There are 7 chances for this to equal false. If it equals true, then we style it. So we take that selector and we actually just break it down into 2 parts. This is the subject. This is also called the key selector, the thing just before the curly brace. This is what we care about. That's the only bit of this selector we actually care about. That's the only bit of this selector that will get styled. Everything else is complexity. Everything else is a condition or a caveat. This is what we need to get rid of. So the problem with a selector like this is we started really ambiguously. We asked a really vague question. We asked, is there a span? Of course there's a span. Of course there's going to be a span. Because we made such a wide sweeping question, we have to then write really complex stuff in front of that to whittle it down. We have to add a lot of cyclomatic complexity. The way we fix this is just by starting as explicitly as we mean to. Instead of asking if there's a span and working back, we should just ask the browser, have you found this class? This has a cyclomatic complexity of 1. It's either yes or no, and then it can bail out and move on. So reducing cyclomatic complexity is about getting rid of nested or qualified selectors. They carry a much higher cyclomatic complexity. The problem as well is that higher specificity if we're nesting, higher fragility, more chances for the selector to break. Long selectors are just generally bad news. Get straight to the point. Start as explicitly as we intend to. Start with the correct subject, and then you can remove all the checks. You can remove all the nesting and the conditions quite freely. James, who spoke yesterday, I shouldn't do this because he's not here. He had to get a flight. I'm going to do it. He wrote this once. Me and James are really good friends. We've known each other for years. He wrote this about 5 years ago when preprocessors were just becoming a thing. And I'll abstract it out to here. So preprocessors sell nesting as a feature. And a new developer gets a preprocessor, scopes everything to the top layer of the DOM, and goes right down. Now, the cyclomatic complexity here is 12. There are 12 potential chances for this selector to break. There are 12 checks in this selector. The funny thing is, if you delete all this, it still works. You don't even need any of that added specificity, any of that added complexity, any of that added bloat, because when you've got things in selectors, when you've got data in selectors, you can't use minifiers to get rid of that. A minifier will never touch your selectors. It's way too risky. So you can't gain any performance wins by putting a minifier over this. It's completely wasted. Who's heard of the OpenClose Principal? Okay, quite a few of you, that's good. The OpenClose Principal, second question then. Who in here worked with other people's code or legacy code or in a big project? Yeah, okay, cool, a lot of you. I would say that the OpenClose Principal is probably the most useful principle for people who work on teams or in teams, on large projects, on legacy projects. Now, unfortunately, the OpenClose Principal is really badly named. About 50% of the useful information is completely missing from the title. The OpenClose Principle basically states that everything, every software entity, should be open to extension but closed for modification. What this means is once we've made something, we can't go back and change it. If we want to add any changes or we want to make any new features, we have to add that via extension. This is kind of counterintuitive, because when we talk about bloated CSS, it's because people haven't gone back and changed things, they've just added things. But this is a fantastic defensive strategy for working in large teams. If you need to make a change, always change things forward. Never go back and change something that already exists. Imagine it's January, and you've just made a class. And you push that to the central repository, and then your colleagues start using that class in their work for the next few months. And in July, you want to go back and change it. Now, the problem is there are 8 other developers relying on how that class works. You can't risk going back and changing it. It's way too risky. Going back and changing things at its source will have a ripple effect. It will have a domino effect. Those changes will be pushed out, whether people want them or not. So it's a defensive strategy for working in teams. You'll get visual regressions that are hard to keep an eye on. You will damage other people's work. Like I say, it's very counterintuitive. We're told that we should go back and change things. Unfortunately, in the real world, it's not always as simple as that. There's a really nice excerpt from the Wikipedia page. The only time you go back and change anything if it's a genuine error. So a class could only be modified to correct errors. If there's a genuine bug, if there's a typo in your RGBA, if you've genuinely set the wrong padding. The only time you go back and change a class is if it's actually wrong. Any feature request, any new additional feature, you have to add that via extension rather. You would then add another class to add that requested feature. We build everything forwards. So let's say we've got a button with 1 em of padding and 2 ems of padding, and we want to change this. Once we've put this out there, we can't go back. We can't go back and modify this. If we want to change the size of a button, we could do something like this. We could create a new context for a new button and say, right, well, you're going to live in here now. The problem there is we've increased our cyclomatic complexity and we're mutating state. Right? We're modifying the base button class. Button now has 2 potential outcomes. Again, the fix for this is really simple. We have to create a new variant. We create a new class to add this requested functionality. Even if it's not requested functionality as an addition, even if this is a requested change, we have to add that change via extension. So it's a safe way to make changes because everything gets opted into explicitly. Here's the best bit about this for me. If you go back and change how a class behaves, you make that change in the CSS, you hit save, you refresh the browser, and your view looks different. You can implement a change by making it in one place. That's not very safe. By having to add the class to your DOM as well, you've got a second safety net. You add a new class in the CSS, you make the change there, then you have to explicitly go and find the bit of the view you want, put the class in there, save that, then hit refresh, then you get the change. You're not enforcing changes anywhere. You have to explicitly opt into every single one. It's a very safe way of working with legacy. The next principle, who's heard of orthogonality? Do you want to do this bit? Oh, you said, oh no, I thought you were terrified. Orthogonality, this is it's only recently that I've begun looking at applying orthogonality to CSS. Orthogonality is a software engineering principle that states that you should be able to use features of a language in arbitrary combinations and still get consistent results. You should be able to use things in a random order and still get the same output. Applying this to CSS is fairly simple. The reason orthogonality is a good thing is because it reduces interdependency. If you can jumble up the order of the features you use and still get the same output, it probably means that those features don't rely on each other. This therefore implies you've separated your concerns very well. It reduces collisions. It means that if we can jumble things up in the DOM, if we can use things in an arbitrary order, the chances of those ever affecting each other is very slim because obviously they don't even know that each other exists. A really good benchmark, a really good simple test for whether your CSS is orthogonal is if you can just randomize the imports. If you can randomize the imports of your components and the view still looks the same, the implication here is that you've got an orthogonal system. The implication is that none of these modules actually collide or rely on each other. This is a hallmark of a very flexible and modular system. We strive for modular UIs. We strive to make UI toolkits that we can compose UIs from. Orthogonality really helps us with that. Another good test is, will it nest? If you can nest things in the DOM without any collisions, you've probably got orthogonal CSS. And the key here is your selectors. 95% of your CSS architecture lies in the selectors that you use. Well-scoped selectors will improve orthogonality. I have an example here. I really hope you can see it. If not, the slides are already online, so I'll post a link to those. But what we've got here is we've got a testimonial title class. But the problem is we've got a collision because the promo class up here has got a nested selector. We've got what's called a subtree collision. We've put something inside another part of the DOM, and there's a crossover. The promo H3 selector can collide with the H3 that's way further down the DOM. Testimonial and promo have got nothing to do with each other. But what's happened is we've mutated the testimonial title class by using an improper selector further up the DOM. This subtree collision can be avoided by just not using nested selectors, by not putting DOM or HTML into your CSS selectors. The collision's completely gone. Testimonial title is not affected by the promo H3 because instead of using promo H3, we're using promo title. So the quality of your selectors will also increase orthogonality. Orthogonality gives us confidence to arbitrarily build bits of UI without having to worry about these subtree collisions, regressions, or anything like that. Okay, the final principle I want to talk about, I actually coined myself. Now, the mustache principle is a very philosophical, very high-level principle. And it was actually invented quite a while ago, but I use it with clients to just explain that, look, you could go and use the new shiny, you could go and do this. is there a valid reason? And what I find really nice, and it kind of wraps this story up really nicely for me personally, is that my father helped me invent this principle. Because really, just because you can, it does not mean you should. Look at that. Thank you very much for listening.